In this video, I want to show if it is possible to generate charts just from commands in natural language. I've built an application called NLP2Chart that's able to generate charts, different types, just from commands put into this input line on the top of the application. Let's start with some simple plot. Let's plot a sine function from, let's try minus pi, for example, to 2 times pi. Click on plot. The application is just generating the chart. See, yeah, we plotted the sine function. In the application, it's possible to save this chart as a PNG file or even as an HTML file. So let's take our input and try some different versions. For example, we could try to plot from 8 times pi up to minus 8 times pi up to 8 times pi, or some other numbers. Okay. So another sine function is generated. Let's try some other functions. Try an exponential function, for example. Plot exponential function from, let's say, minus 2 up to 2. Generate plot. And after 1 second, we see the chart is plotted. The next step, we could try to combine more than one function. Take my last command, plot an exponential function. Let's try the sine function together with the exponential function with the same bounds. Yeah, and the two functions are both plotted inside. So we could try to refine our command back with the last command. For example, I would like to say, I would like an y-axis on a different scale. Let's say we want up to a limit of 10, for example. Let's say, and set the y limit to 10 to and we get the functions with different axis limit. Let's try another step. Maybe we would like different colors in our charts. Take, for example, green for the x function to regenerate our chart. And we get a green plot for our chart of the x function. In the next part, I will generate some graphics from random numbers, generate some random numbers, and make some different types of graphics. Let's start with an histogram. Plot the histogram. Let's take random numbers. Let's take some normal random numbers, normal distributed. Mean 5. Variance. For example, let's take 2. Plot we will get an histogram with mean 5 and variance 2 from random normal distributed numbers. As a second example, I will try some line charts. First, we will create some data for the line chart. Let's create a data set. Random numbers for each day, for example, of a year 2020. And then we would like to plot this random data. Plot a line chart from this data set. And let's click plot, see what's happened. In the next part, I will show some graphics from data from random numbers. I will generate different types of random numbers and visualize them. Let's start with an histogram. Plot a histogram of, let's say, random normal numbers. (300) random normal numbers with some mean 5 and some variance. It's 2. Plot to generate the chart. It's a typical histogram of random normal distributed numbers. Second example is, let's try some sort of line charts. We create the data for first. Create a data set. With some random numbers for each day. Let's take the year 2020. For each day, we would like to generate a random number and then plot a line chart from this data set. Plot the line chart. And we'll get this random chart, random numbers over the year. We take this command and make some refinement. Maybe we would like to label our lines, then extend them to more than one data column. Let's first extend with the name the column cases, for example. Plot. And we get a label for cases in this command. Now I would like to extend to a more complicated example. We create a second data column. Not only the random numbers called cases, we create a second create a column. Also with random numbers. And call it for example. And then we would like to plot a line chart for both for the cases and we have now two charts, two line charts, one labeled cases and one labeled deaths. We now want to refine this command just to view some part of the cases and the deaths over the year. Let's, for example, take our last command, copy and paste it, and maybe we just want to plot all the cases from May. So now the chart should plot only some part of the dates, and we will see, of course, the starting 1st of May, and then the data, the random data, is generated up to end of May. This works perfectly. Let's try different charts. Let's make some other histograms. For example, make array of random numbers, say some 40 random numbers, plot a horizontal histogram. Let's try the plot. And we have an horizontal histogram. Let's check if it's just, if we just take another number and some vertical histogram, it also works. And we'll get a vertical histogram. Next, we would like to try some other labels at the axis and try to refine this command. Take the last command, and let's say we would like to label the y-axis as, for example, some counts. Let's label them as counts. And the x-axis is now labeled as count and not the y-axis. So this didn't work quite well. Now let's do some scatter plotting. We just generate some numbers, create list numbers, let's say from 1 to 20, not random numbers, just the numbers from 1 to 20. And let's create also some random numbers. List of 20 random numbers Then let's combine them to a data set. And then let's plot them. Scatter plots. And we have a nice scatter plot from numbers from 1 to 20, a scatter plot versus plots of 20 random numbers. Now let's analyze some real-world data. I have a data set of COVID-19 data, and I want to try some plots on this data set. Let's start with a line plot. Make a line plot of total cases. That's one of the fields available. Plot it. And we get an empty plot. So maybe there's something wrong. We did not load our data set. So let's extend our command with some loading of the data. Load COVID data, CSV, data CSV into the data set. And make a line plot of total cases per date. We see all the numbers of total cases plotted over the timeline. There are other fields available. You can click at our COVID-19 data. You see all the fields that were available for further plots, and we will use them in the next examples. Now let's try to generate some pie chart, for example. We just load our data set, and then we first group our data by continent, and plot, for example, the new cases per million as a pie chart. Let's try this pie chart. And we will see a pie chart for all of these examples. After the pie chart, let's try some bar charts, for example. Start by loading the data set. After loading the data set, we want to plot the sum of total cases. And we group them by location. And would like it as a bar chart. And let's plot it. And we will get, of course, a bar chart, but we have a lot of locations for all of the countries in the world. There are cases available, so that's not a good readable bar chart. So let's try to define this bar chart. we'll take the last command and let's restrict for, let's say, for the first 20 locations of the bar charts and sort them. Let them by location, and for the first 20 locations, there's a bar chart, and we will try it sorted. Try to plot a sorted bar chart. And we get the correct cases. Of course, the labeling could be better at the x-axis, but the bar chart is correct. Let's try some bar chart about vaccinations. We start by loading our data set, and then group will now take people vaccinated, group them by location again, make a bar chart. We will take the first 10 positions, for example. Bar chart, the top 10 locations. We could try to name the X or the Y axis as, for example, would like to label it people. So let's try this complicated statement, see if it works. So it partly worked. We get the bar chart of the first 10 locations, starting with world and Asia, the vaccinated people, but we did not get the right y-axis as people, so it worked. Yeah. Now let's try to make some grouped bar chart. Let's look at it working. We load our CSV data set as before. We make a grouped bar chart of total vaccinations and people vaccinated, and we will plot the first 10 locations. So let's try to look at the chart. And we get some grouped bar charts for the top 10 locations. Next, we will make some scatter plots on the COVID-19 dataset. By loading the dataset, load the COVID-19 CSV into a dataset. Then first, group our data, total cases, and the total deaths, and the total death. They are grouped by location. And then we will make a scatter plot. Make a scatter plot of them. Let's try the plot. Yeah, and we see a nice scatter plot of total cases versus total deaths. Wouldn't it be nice to plot a regression line for this linear dependency between total cases and total death? Let's try. Start with the same command as before, and we extend it as and regression line and the regression line. This shows up a nice regression line for this data set. Now let's try some histograms over the COVID-19 data set. We load the data set. Make a histogram. Of one of the variables. We will take the positive rate. And we need some bins. 20 bins for this histogram. And we have a histogram. Maybe we could try different bin size. 40 bins. And get the bin size with smaller steps. And the last example for the COVID-19 dataset, try some box plots. Loading the dataset. And make a box plot of two of the variables. The ICU patients. And the number of people in hospitals. Try a box plot. Here's the box plot for these variables. Now some examples with the second data set. Some data from Gapminder containing information about population of different countries and life expectancy in these countries. And we will use this for some other examples. Start by loading this other data set. Maybe try with open. Find the data point.csv. And then plot a bar chart of population per continent. We get the population, total population per continent. As a second bar chart, we could try the life expectancy. For example, for these continents, we change our script for and the other variable, life expectancy per continent, is plugged in. And we get the different life expectancy from Africa to Oceania. Now some line plots for the Gapminder dataset. Starting with loading the CSV file, and then we will try to sum up over the total population over country, over the variable country, and then plot per year. So we summed up and split it by country and get all the increase of population per country. We could also try to do the same thing with the continent instead of country. And also plot per year. It's a chart of the continent. Next, some bar charts, beginning with open the dataset. Let's try with the mean of the GDP per cap for our first example. And over the continent. Try the result. Oh, we get an empty chart. Oh, we have forgotten to extend the plot command. We just summed up the mean, but we didn't do as a plot as a bar plot. Maybe then it will work. Yeah, we get a bar plot with summed up GDP per mean per continent. Try some more complicated bar chart. Try a stacked bar chart. Starting with loading the data. Then, after loading the data, we group our data. We group the population by continent and year. And then make a stacked bar plot. And we get a stacked bar plot for all the continents. This last example, we try to do some scatter plots on the Gapminder dataset. Loading the Gapminder CSV, make a scatter plot of population versus life expected. We have our scatter plot. We could refine these, for example, try to color the dots by, for example, the GDP. Try the plot. Now we have also the scale, the color scale for this scatter plot.